Okay, on these notes, we're going to be using these rules right here that you need to have memorized. The sum and difference, they're called sum and difference rules because basically if you have two angles that you're adding together, it will always work out to look like this. You take the sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. Notice with the sine function, when you have a plus sign right here, you have a plus sign right here. It's always the same. Same with sine. With cosine, however, when you do the plus, it's going to have a minus. And cosine does both the cosines together and then the sines together. So just, you kind of got to memorize those formulas. So figure out a way to get them stuck in your head. All right, so basically what you're doing is, like, if I took sine of 75, that is not on the unit circle. It's not one of those reference angles that we always use. So but you can combine two angles to be that reference angle. So, like, think about how pi over 4, or no, actually, let me scratch that. We'll come back to that. Think about how sine of 75 is the same thing as sine 30 plus 45. So using our rule up here, because we are adding numbers, we're going to use that one. We'll say, 30 will be my u and 45 will be my v. I'll do the sine of 30 cosine of 45 plus same sign for sine, cosine of 30 sine of 45. And then you're going to evaluate it. Sine of 30 is the same thing as 1/2 using my unit circle. Cosine of 45 is the same thing as square root of 2 over 2. Cosine of 30 is the square root of 3 over 2. And sine of 45 is square root of 2 over 2. And then multiply those fractions straight across, so that gives me square root of 2 over 4 plus square root of 6 over 4. And you can combine the numerator since you have a common denominator, so it will look just like this. So that's what sine of 75 is. Okay. Now let's do cosine of 5 pi over 12. Now I can write all that out that I was trying to write earlier. So think of how pi over 3, which is a 60-degree reference angle, is, if I had a denominator of 12, that'd be the same thing as 4 pi over 12, because we multiply the top and bottom by 4 to get that. Pi over 4 is the same thing as 3 pi over 12. Pi over 6 is the same thing as 2 pi over 12. And then, you can do all of the angles on the unit circle using that. Like 7 pi over 4 is the same thing as 21 pi over 12. And then you just choose a combination that would give you that 5 pi over 12. Well, I can choose 3 pi over 12 and 2 pi over 12. Those will add to give 5 pi over 12. So cosine of 5 pi over 12 is the same thing as cosine of 3 pi over 12 plus 2 pi over 12. All right, now plugging it in to this formula right here. This is my u and this is my v. So cosine of 3 pi over 12, well, you know what? I don't want to think about them as 3 pi over 12 anymore. I want to think about it as pi over 4. And 2 pi over 12 is the same thing as pi over 6. So think about them in those terms. Sorry about that. All right, so cosine of pi over 4 times cosine of pi over 6. Different signs with cosine. So now sine pi over 4, sine pi over 6. And now just evaluate them. Cosine of pi over 4 is the same thing as square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2. Sine pi over 4 is square root of 2 over 2. And then sine of pi over 6 is 1/2. Multiply straight across, and we get square root of 6 minus square root of 2 over the common denominator 4. And that's your answer. Okay, on letter C, we're trying to get sine, pi over 12. So I could use these two and subtract them. So that'd be sine of 3 pi over 12 minus 2 pi over 12. Now, I could have also used the 4 pi over 12 and the 3 pi over 12, but it doesn't matter. You're going to get the same answer. So that's sine of 3 pi over 12 is pi over 4, and 2 pi over 12 is pi over 6. So now we can just use the this one because we're subtracting them. This is my u, this is my v. So we'll do sine of pi over 4, cosine of pi over 6, minus cosine of pi over 4, sine of pi over 6. So that's going to be square root of 2 over 2, square root of 3 over 2, minus square root of 2 over 2, 1/2. And then that gives me square root of 6 minus square root of 2 over 4. And that's my answer. Okay, this next example is a little different. They've already got it spread out. Remember up there, notice I've got sine and cosine together, so that's the one for the sine. And sine always uses the same sign, so they're doing sine u minus v. Remember that formula was sine u, cosine v, minus cosine u, sine v. So what they've done is, I'm going to write it in like this. I'm going to say sine, and my u is 42, and my v is 12. So I'm saying 42 minus 12, which is sine of 30. And that's real easy. That's just 1/2. And so I evaluated it. On the next one, they have cosines together and sines together. So they use the cosine, and that's a minus. Cosine uses opposite signs. So they use the formula cosine of u plus v, where my u is the 5 pi over 36 and my v is pi over 9. So we're going to write it as cosine of 5 pi over 36 plus pi over 9. I need to get a common denominator. Remember, pi over 9 is the same thing. I multiply the top and bottom by 4. So it's the same thing as 4 pi over 36. So when I add those, I get 9 pi over 46 or 36, which is the same thing as pi over 4. And then cosine of pi over 4 is just square root of 2 over 2. And so I've evaluated it. All right, on the next example, they have me doing sine of u is 4/5, and they've told me what quadrant I need to be in. It's got to be between 0 and pi over 2. Remember, 0 is here, pi over 2 is here, so they want me drawing it in this quadrant. Sine is y over r. This is a 3, 4, 5 triangle. So this is angle u. Angle v needs to be in the quadrant pi over 2 to pi, which is in the second quadrant. And cosine is x over r. This is a 5, 12, 13 triangle, so this is angle v. So now you can use your formula. They want me to find the exact value of sine u plus v. So they want me to do sine of u, cosine of u, cosine of v, plus cosine of u, sine of v. Now I'm going to use those triangles. So for u, sine of u, I know it's 4/5. For cosine of v, I use this one, which was negative 12/13. Plus cosine of u, I'm back to this one again. Cosine is going to be adjacent over hypotenuse, so it's 3/5, or x over r. And then sine of v, I'm back to this one. It's going to be 5/13. So multiply fractions straight across. 4 times negative 12 is a negative 48. 5 times 13 is 65. Plus 5 times 3 is 15 over 65. And then add those fractions, or in this case, subtract them. And we'll get negative 33 over 65. And that's my answer. Okay, this next one's a little tricky. They're wanting me to do cosine of two angles being. Remember, anytime we do arc tan or arc cosine, those are representing angles. So this is technically my angle u, and that's my angle v. So arc tan is 1. That means I'm in this quadrant, because arc tan had to be in the first two quadrants. It's positive in the first quadrant, negative in the fourth quadrant. arctan, it's 1, so it's y over x. They're both going to be 1. And I would get that this is square root of 2. And then on the V angle, all they're telling me is arc cosine. Cosine uses these two quadrants. So in this quadrant, they've got x over, they've got arc cosine of x, which is x over 1. And remember, cosine is x over r, so x is going to just go here, and then on the unit circle, this is just going to be, and they've told us here, this is just 1. And then to get this other side, we have to do Pythagorean theorem. Remember, x squared plus, I'm going to think of that as b right there. B squared equals 1 squared. Solve for b. So you get 1 minus x squared. Then take the square root. So you get the square root of 1 minus x squared. So this side over here is the square root of 1 minus x squared. Okay, so remember, this is my angle U, and this is my angle V, and we're doing cosine of those two added together. So cosine of U plus V, our formula is cosine U, cosine V. The more you write this formula, the more you're going to remember it. Cosine uses an opposite sign, and then it'll be sine U, sine V. All right, just use those triangles now. Go to this one for U. Cosine is adjacent over hypotenuse. Cosine V, we go to this one, was just x over 1. Minus sine U, back to this one. Sine was 1 over square root of 2. Sine V for this one would be square root of 1 minus x squared over 1. Multiply straight across, you get x, and then minus the square root of 1 minus x squared all over the square root of 2. And technically you could rationalize that, but I think this is fine. All right, on the next one, they want me to prove the cofunction identity. So using our sum and difference rules, we already have this formula on our formula sheet, knowing, the cofunction rules, but we're going to prove it. So I'm going to use cosine of U minus V. I'm going to write it down here just to remind us. Okay, so we're going to plug that in. Cosine of pi over 2 cosine of x plus sine pi over 2 sine x. Okay, remember at pi over 2, we have the order pair 0, 1. So cosine is 0, and sine is 1. So this just goes away, and we're just left with sine x. So we verified that that's the same thing. All right, on the next one, I'm going to rewrite my rule over here just so we don't forget it. It's cosine U, cosine V, plus sine U, sine V. So I'm going to expand this. So that'll be cosine of theta, cosine of 3 pi over 2, plus sine of theta, sine of 3 pi over 2. All right, so 3 pi over 2 is down here. So we'll do cosine of theta, and cosine of 3 pi over 2 is just 0, plus sine of theta, and then sine of 3 pi over 2 is negative 1. So that goes away, and we're just left with negative sine theta. So I have simplified that one. On the next one, remember your tangent rule of U plus V. It is tan U plus tan V over 1 minus tan U tan V. All right, so plugging that in, I'm going to have to get some room here, sorry. All right, plugging this in, this is U and this is V. So tangent theta plus tangent of 3 pi over 1 minus tangent theta tangent of 3 pi. 3 pi is going to end up right here at the order pair -1, 0. So remember, tangent is y over x, so it's just going to be 0 over -1, which is just 0. So that'll be tangent of theta minus or plus 0 over 1 minus tangent theta times 0, which means it's just 0, equals tangent theta over 1, which is just tangent theta. And that one's simplified. All right, I'm going to work A, and it's going to take me a lot of room, so I'm probably going to let's ignore this for right now. And let's work with this one. So I'm going to have to expand this to solve it. So I'm going to expand this one first. I'm going to really write big. So sine x cosine pi over 4 plus cosine x sine pi over 4. So that's the first one expanded. Now we've got to expand this one. So plus sine x cosine pi over 4 minus cosine x sine pi over 4. And all that equals 1. All right, remember, let's see, looking at this, we can simplify real quick. These two are going to cancel, so they're gone because one's positive and one's negative. Then we've got sine x. Cosine of pi over 4 is square root of 2 over 2. You know what? Before I do that, I've got two of these right here. So I'm going to combine that to be 2 sine x cosine pi over 4 equals 1. I could go ahead and divide by 2. Oh, sorry. So that gives me sine x cosine pi over 4 equals 1/2. Okay, now I'm going to change cosine of pi over 4 to be what it is, which is square root of 2 over 2. So now we're solving for sine x. I'm going to multiply both sides by the reciprocal of that. So that leaves me with sine x, these cancel, equals, over here the 2's cancel, I'm left with 1 over square root of 2. And technically that's the same thing as square root of 2 over 2. Remember, sine is positive in the first and the second quadrant, and that's a pi over 4 reference angle. So x will equal pi over 4 in the first quadrant, and it will equal 3 pi over 4 in the second quadrant. They didn't say 0 to 2 pi, so I have to give all the solutions, which means I need to add the period. And that's just going to be 2 pi in and 2 pi in for those two angles. And remember, n is the set of all integers. Okay, that's it for A. Let's do B next. So now I'm ignoring this one. And then expand the first one. So sine x cosine of pi over 2 plus, plus cosine x sine pi over 2. Then expand the second one, so sine x cosine of 3 pi over 2 minus cosine x sine 3 pi over 2 equals -1. Okay, on this one, let's see. Is anything going to cancel? I don't think anything cancels here because we don't have any like terms that are going to cancel. But I want you to remember, like at pi over 2, we have the order pair 0, 1, and at 3 pi over 2, it's 0, -1. Remember, that's pi over 2, this is 3 pi over 2. So cosine of pi over 2 equals 0, and cosine of 3 pi over 2 equals 0. So I know that this whole thing will be 0. I know this whole thing will be 0. So that kind of helps me. I know that the sine of pi over 2 equals 1, and the sine of 3 pi over 2 equals -1. So I can plug those in. I've got cosine of x, I'm rewriting this one, times sine of pi over 2, which is 1, minus cosine of x times sine of 3 pi over 2, which is negative 1, equals negative 1. So this negative here will combine with that negative to be a positive. So we'll have cosine x plus cosine x equals negative 1. These are like terms that can be combined to be 2 cosine x equals negative 1. Divide by 2. So you're looking for an angle where cosine's a negative 1/2, which is going to be in those two quadrants. And that's at a 60-degree reference angle. So x equals, in the second quadrant, 2 pi over 3. And we're doing the general solution again, so add the period. And then in the third quadrant, it's going to be 4 pi over 3. And add the period to it. And that is my general solution for that one. Okay, on this last one, I'm going to expand this out. Or actually, I'm expanding that out. So it will be cosine of x, cosine of h, minus sine x, sine h. Oops. And then that's expanded, so now finish it out. So now minus that cosine x, all of which is over h. So we're trying to verify that this left-hand side over here equals the right-hand side. So we're trying to make it look like this. Okay, so let's look what we can do here. I'm going to put this over here, group it to where that's together. So we've got cosine x, cosine h, minus cosine x, minus sine x, sine h, all over h. That way I can work with these two right here, those two terms, and factor out to kind of make it look like these two right here. So factor out my greatest common factor, and I'm left with cosine h minus 1 when I do that, minus the sine x sine h, oops, all of which is over h. Okay, so they've then broken it up into two separate fractions. They're kind of going to break it up to where we've got this fraction right here, and then this fraction right here. So we'll write it as cosine x, and then we've got cosine h minus 1 all over h minus sine x, and then sine h over h. And then it's been verified. All right, that's it for these notes. Thanks, y'all.